This is 5.5, inverse functions. What is a function? A function begins with an input, and you take that input and a mathy thing happens. Something mathy happens to your input. And the things that are mathy that can happen include addition and subtraction. So you could add or subtract something to your input. You could multiply and divide. You could square and square root. So there's all sorts of mathy things that can happen. And then what happens is you take your input, a mathy thing happens, and you generate an output. If we give you a function maybe that looks like this, if you were to plug a number in for x, what is the first thing you would do? You'd add 2. And then after you add 2, you'd square it and then divide by 3. So this is a do list. You take your input, and these are the 3 mathy things that you're going to accomplish in this order. First, add 2 to your number. Second, square it. Third, divide by 3. What we'd like to do to continue this idea is we would then like to take the output and we want to apply another mathy thing. And this is the inverse function. And when you take that output and you apply it to the inverse function, what you get is your original input. If you think of a function as the do, you can think of the inverse function as the undo. An inverse function undoes a function. If my do function is addition, what is the undo function? Subtraction. Yeah, this is easy. And you learned this in elementary school. The first thing you learned to do was add numbers. Once you got really good at adding numbers, you learned to unadd numbers. We didn't say unadd, we called it subtraction. Addition and subtraction are the same thing. One's the do, one's the undo. After you got really good at adding, you started multiplying. What's the undo of multiplication?
Division.
Division. So division undoes multiplication, and multiplication undoes division. Do and undo. Then we started doing things like squaring. So what is the undo function of squaring? Square root. Why does the square root exist? To undo the square function. So these ideas, these operations are always developed in pairs. And not to get too philosophical on you, but it's like yin and yang, up and down, black and white. They're kind of like 2 parts of the same thing. So let's go back to, now that we have this list, let's go back to our function. F of x equals x plus 2 squared divided by 3. And let's create an undo list. And this undo list will be the inverse function. We started by adding 2, squaring, and then dividing by 3. So what should we do to undo this process?
Subtract 2.
Yeah, subtract 2. And then after you get done subtracting 2, square root. And after you get done square rooting, multiply by 3. Okay, this is wrong. Most students say, well, why is this wrong? So what I'd like to do is I'm going to change my do list here to something that might make a little bit more sense. So here's a do procedure. Put on socks. Put on shoes. Tie shoes. It's a process that we do almost every day. You put on your socks, then you put on your shoes, then you tie your shoes. What's the undo process? What is the first thing you do to undo this process? Is it take your socks off? No, because you got your shoes on, right? That would hurt. What you have to do is not only do you do the inverse operation, but you have to do those operations in the reverse order. So the first thing we do is we untie shoes. The next thing we do is we put on shoes. Now we don't say put on shoes, we say just take your shoes off, right? Just like we don't say unadd, we say subtract. And then the last thing that you do in this process is you put on socks. So not only do you do the inverse operation, but you have to change the sequence with which you do those operations. So if we go back to our list over here and we do this undo process of our function, the first thing we need to do is multiply by 3. And then we square root, And the last thing we do is subtract 2. Follow this procedure and it will give you the inverse function. This would be the inverse function. And to write the inverse function, we write f of x to the negative 1 power. So if we have f to the negative 1, and I give you an input, we start with x. What is the first thing you do with x? Multiply by 3. So this becomes 3 times x. What's the next thing we have to do? Square root. And then what's the last thing we need to do?
Subtract 2.
Subtract 2. That is the inverse function. So here we have a function. The blue box is the function, and the red box is its inverse function. F of x equals 10 times x plus 4. And so if you were to create a do list, you would say multiply by 10 and then add 4. That's what this function does. You take any input, you take that input, you multiply it by 10, and then you add 4. So what is the undo list?
Subtract 4.
Yep, subtract 4 and then divide by 10. So if we start with an x, the first thing we do is we subtract 4 from it, and then we divide that whole thing by 10. And this would be the inverse function. The blue line goes through the point 4, 0. The red line goes through the point 0, 4. Y equals x. X equals y. The graphs are symmetrical. This point has coordinates -6, -1. What would happen if we flipped those x and y's? What coordinates would you get? -1, -6. -1, -6. What can you say about the graph of a function and its inverse? X equals y and y equals x. We're reflecting this about what line? X equals y. So it's saying every x coordinate in the function becomes a y coordinate in the inverse. And every y coordinate in the function becomes an x coordinate in the inverse. Here's another way to look at it. If you were to make a table of points, x and y, and you put in -2, -1, 0, 1, and 2, and maybe your y function gave you 4, 10, 16, 22, 28. If this is your do function, then your undo function is going to be x, y, 4, 10, 16, 22, 28, -2, -1, 0, 1, and 2. You swap the x and the y. Graphically, you swap x and y. Table-wise, you swap x and y. And now, let's look at the function. If we took this function and the first thing we did was we swapped x for y, what would you get? Remember, this function is y equals 10x plus 4. So if you swap x and y, you're going to get x equals 10y plus 4. And then your second step is you solve for y. So how would we solve x equals 10y plus 4? Our first move, subtract 4 from both sides, divide everything by 10, and you get x minus 4 divided by 10 equals y, which is that function right there. Y equals 2/3 x plus 4. That is the function. And I'm going to do the inverse in blue. So the first thing I'm going to do is I'm going to swap x and y. You exchange x and y. What you're doing graphically is you're flipping that x and y coordinate. You're folding the paper on that 45-degree angle. So this becomes x equals 2/3 times y plus 4. So all you do is you do a simple swap x and y. Your second move is solve for y. Subtract 4, multiply by 3/2, and so that means we have to multiply this by 3/2. So your inverse function is going to equal 3/2 times x minus 4. So again, I'll do the function in red. So I'm going to say f of x equals 7 plus the square root of 6x minus 6. Swap x and y. So everywhere you see a y, you put an x, and everywhere you see an x, you put a y. And this is the inverse function. We're kind of like done. The problem is we like things to say y equals, not x equals. So now we have to manipulate this and solve it for y. Subtract 7. Square both sides. Add 6. Divide everything by 6. So the inverse function is equal to x minus 7 squared plus 6, all divided by 6. There's a lot of symmetry built into this thing. Okay, here's one more function. Find the inverse function. Swap x and y. What's your first move in getting y by itself? Subtract 5. What's your next move? Divide by 2. What do you do next? Let's go through our operations. Can you add or subtract something from both sides to get y by itself? No, we can't. So this is out. What about multiply or divide? Could we multiply or divide by something to get y by itself? No. Could we square or square root? We can't add and subtract. We can't multiply and divide. We can't square or square root. So to solve this, we need to be continued on Monday.